Hello everyone, welcome to section 5.1 and section 5.2. Today we're just looking at actually using our primary trig ratios for trigonometry. If this is your first video, please go back and make sure you're watching the review of trigonometry. Okay, so we had a little bit of a review in our other file. Please go back and see it. Today we're actually going to be using these. So remember, sine of an angle is always your opposite over a hypotenuse, cos of an angle is adjacent over hypotenuse, and tan of an angle is the opposite over adjacent. When you get to a problem, the first thing you do is label your hypotenuse, identify the angle that you want to work with, and then label the other two sides in relation to the angle that you want. And then depending on whether or not we're solving for a side or an angle will determine how we handle the rest of the question. So let's do a straightforward example. We're going to do one where we find a side and one where we find an angle. So looking at this example right here, we have a right angle triangle. There is my 90 degree. I am looking for a side, and the side across from my angle is my hypotenuse. So since I'm looking for a side, my math will become pretty straightforward. I'm just going to be using sine and then my numbers in my calculator, or cos or tan. So let's figure out which trig ratio I need to use. So I'm going to determine or find the angle I'm going to be working with. They gave me the 34 degrees. That's the one I'm going to label everything in relation to. So this angle here, the x, since this is what I need to find, I've got to have that in my equation, is my opposite because it is across from the 34. The 5 is beside the 34, so this is my adjacent. Okay, so since I'm going to be dealing with an opposite and an adjacent, if you think about Sohcahtoa, let's just write it up here, Sohcahtoa. Out of the three trig ratios, O and A is tan. So this is going to be solved with tan. Okay, so tan of my angle is going to equal opposite over adjacent. Oops. All right, let's go to our pen tool. So we're going to write tan, and now we're going to substitute all of our values into our trig formula or our trig ratio. So the angle is 34, so tan of 34. Okay, because remember, sine, cos, and tan have to have an angle beside them. So tan of 34 is going to equal my opposite divided by my adjacent. My opposite, I don't know what that is. Okay, it's going to be x, and then my adjacent is 5. So whatever this decimal value is, because tan of 34 is just a number, so this is going to be some decimal. Whatever this decimal is going to be equal to the ratio or the fraction of whatever x divided by 5 is. So we have to figure out what x is. So we can do a little bit of algebra. And I just have to get the x by itself. So I'm going to bring the 5 onto the other side. Since the 5 is being divided, when I bring it over, I'm going to multiply. So this is going to be 5 times tan of 34. And then equals x. Okay, so you can take your calculators, plug all of this in. Tan of 34 is approximately 0.67. Keep at least 4 decimals in, and then I'm going to multiply by 5. When you do that, you should get about 3.3725. Okay, and keep your rounding rules. Keep about 3 or 4. If the question here asks to the nearest centimeter, so we would be looking at just 3. Write down a few decimals, though, please. Just to make sure that you are getting the correct answer when you go to the back of your book. Excuse me. Okay, I do want to do one more because I want you to see what happens if my unknown is on the bottom of a fraction. So let's look at example number 2. Here is my angle. This x right here. So if you look at it, here's my 51. The first thing you should always do is identify your hypotenuse. So there's the 90 degree. This is my hypotenuse. Okay. The 13 is beside the 51. So this is going to be my adjacent, okay, because adjacent means beside. Now, some of you might ask, Miss, the x is also beside. Yeah, but the x is the hypotenuse. So label your hypotenuse first, okay? And that should make it pretty clear which one is the adjacent. All right, so now go A and H, find the trig ratio that deals with A and H, or adjacent and hypotenuse. It would be cos. So cos of your angle, which is 51, is going to equal the adjacent, which is 13, over the hypotenuse. Now in this example, actually I guess we can use x. In this example, you'll notice that our unknown or our variable is on the bottom of a fraction. You cannot solve for these when they're on the bottom. They have to get brought up. So we're going to do a little switcheroo here. This h is going to come up top. I need to multiply both sides by h to get it up at the top of, I guess, of the other side, just like we would have done over here with the number 5. So this is going to be h times cos of 51 equals 13. Okay, now that the h is in the numerator or up top, now I can get rid of the cos of 51. So the cos of 51 is now going to get brought down to the other side. Technically, these are being multiplied, so the opposite of multiplying is dividing. So h is going to be equal to 13 divided by cos of 51. I always recommend that students, if you can do it in one step, that's great, but I always recommend that students do this in 2 steps so you don't get confused with your numbers. So this is 13 divided by whatever cos of 51 is. It is 0.6293, okay? And then your final answer, take 13 and divide by these. You want to keep as many decimals as possible because when you start chopping them off, your answers won't be as accurate. And we want to keep our numbers as accurate as possible. Okay, if you round this, you should get 20.657. If you round, you'll get 20.7. Okay, so if you're looking for sides and your unknown is on the top, it's a straightforward bring the 5 over. But if your unknown is on the bottom of a fraction, you've got to do a little switcheroo over here. The h comes up and the cos 51 would go down. Okay. Let's look at one example where we are finding an angle. I'm just doing one here, and then we'll pause, we'll do some word problems. So if I am finding angle A, okay, step 1 is to identify the angle that you're going to be working with. I'm working with A. Now I have to label my sides. This is my hypotenuse because it is the longest side of the triangle and it's across from the 90 degrees. Now the 3 and the 4, I have to figure out which one is opposite and adjacent. The 4 is beside the angle, so this is my adjacent. The 3 is across from the angle, so it is my opposite. They've given us all 3 sides here, so you have free reign to figure out whichever trig ratio you would like. So in this case, we haven't seen sine yet. Let me look at sine. And it doesn't matter in this scenario which trig ratio you used, as long as you're matching the sides properly. So sine is opposite over hypotenuse. So I'm going to use the 3 and the 5. So sine of my angle is 3 over 5. Whatever this angle is, sine of that angle will be equal to this ratio. So 3 divided by 5 is 0.6. Okay, so sine of A equals 0.6. This, what I'm about to say, I guess is not mathematically correct, but it will help a little bit. In order to get the A by itself, I have to bring the sine onto the other side. It's just like when we, if we have something being added to one side, you do the opposite operation. Well, the opposite to sine A is the inverse sine. Okay, the opposite to cos is the inverse cos, and tan is the inverse tan. So it's sine with this little -1. That's the inverse sine. So A, if I want to figure it out, is actually equal to the inverse sine of 0, inverse sine, there we go, 0.6. This is just calculator work. You can take your calculators, plug in the inverse sine of 0.6, and you should get 36.869, blah, 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 a whole bunch of decimals. If you round, you're looking at 36.9 degrees, or you are looking at 37 degrees, okay? This question wanted us to round to the nearest degree, so we're going to keep the 37. Okay, I'm going to stop the video here, and then we'll get into word problems in the next